Have you ever thrown a rock into a body of water? Did you notice how the rock creates ripples around the spot where the rock lands in the water? These ripples, or concentric circles, are mechanical transverse waves. Mechanical transverse waves are created when an object, like a rock, disturbs the water and sends energy through it in the form of waves. Just like the rock created ripples, vibrations in all sorts of materials can create transverse waves, like sound waves in the air or seismic waves in the ground. There are two main parts of transverse mechanical waves: the amplitude and the frequency. What happens when a large, heavy rock is thrown into water versus a small pebble? The amplitude changes. The amplitude is the height of the wave, and it tells us how much energy the wave has. So, if you threw a big rock into the water, the ripples would be taller and have more energy than if you threw a small pebble. The frequency of a wave is how often the wave repeats. The higher the frequency, the more often the wave repeats, and the shorter the distance between the peaks of the wave. So, if you threw two pebbles into the water, one after another, with a short time between them, the ripples would overlap and form a bigger, more frequent wave. Other examples of transverse waves are vibrations on a guitar string to produce sound waves, the aftershocks of an earthquake, and ocean waves. So, to sum it up, in a simple model for waves, the amplitude of a wave is related to the energy in a wave. Higher amplitude means more energy, and lower amplitude means less energy. The frequency of a wave is how often the wave repeats. The higher the frequency, the more the wave repeats. So, when you're throwing rocks into the water and seeing the waves, you're actually watching a real-life example of mechanical transverse waves in action. Pretty cool, right?